Hi, my name is Emily Vogt, and this presentation is on alkene hydrohalogenation. It's specifically going to focus on the difference between radical and non-radical reactions. A hydrohalogenation reaction is when an electrophile attacks the double bond, breaks the bond, and attaches to the least substituted carbon. This then turns the molecules into the carbocation, which reacts with the nucleophile. In a radical, which is a mechanism with initiation and propagation, it's very similar, except that the hydrogen ends up on the most substituted carbon and the halide ends up on the least substituted carbon, which can be known as an anti-Markovnikov reaction. The halide attacks first because of free radical addition and will go on the least substituted carbon, so hydrogen ends up on the most substituted carbon. The major difference in a non-radical hydrohalogenation reaction and a radical hydrohalogenation reaction is where the halide and hydrogen end up. In a non-radical reaction, the hydrogen will end up on the least substituted carbon, and the halide will end up on the most substituted carbon. In a radical reaction, the halide is on the least substituted carbon, and the hydrogen is on the most substituted carbon. In this radical reaction example, you can see that we have the different steps required for a radical reaction. Step 1 is our initiation portion, and steps 2 through 4 are propagation. In step 1, the bond between the two oxygens break, and it's shared evenly. And then in step 2, the single atom here will meet as this bond breaks, and it'll form H2O. In step 3, this double bond will break, and the bond will be shared between our molecule on the left, and it'll create a new bond with our bromine. In step 4, this atom will form a bond with our bromine, and the bond between our hydrogen and bromine will break and split evenly. In a non-radical hydrohalogenation reaction, so this is non-radical, we start off with our nucleophile over here, and the double bond from our nucleophile will be broken, and a bond will be created with our hydrogen. This will then form our carbocation, which will end up reacting with the nucleophile.